This set of notes is going to be on pages 25 and 26. Page 25 will be simplifying imaginary numbers, and page 26 will be arithmetic with complex numbers. So let's go to page 26. Now let's start on, you know what? We're going to mix things up and start on page 25 tonight. So 25 is the title of Simplifying Imaginary Numbers. And remember that an imaginary number, we said, was anytime we had a square root of -1, and that we could also write that as I. We could simplify the writing of that as I. And remember that when we have the square root of -1 times the square root of -1, we are going to define that answer as being -1. So it will equal -1. So for example, if we have the square root of -32, the first thing we're going to do is break that up into the square root of 32 times the square root of 1. And we know that this is true because if I multiply these together, the square root of 32 times the square root of -1 will get me back to the square root of -32. We can further break this down. The square root of 32 is the same as the square root of 16 times the square root of 2. And we're going to bring down the times the square root of -1. We haven't done anything with that yet. We can continue breaking this down. We know that the square root of 16 equals 4. The square root of 2 does not simplify any farther. And we can rewrite the square root of -1 as I. So we could simplify the square root of -32 into 4 times the square root of 2i. And that is as far as it simplifies. So we're going to work through a couple of examples. So our first example is going to be the square root of -2 times the square root of 8. We can simplify the square root of -2 into the square root of 2 times the square root of -1. Ooh, and I see this is a mistake. This should be a -8 up here. Let's go tuck in a negative. We can simplify the square root of -8 into the square root of 8 times the square root of -1. And here we see that we've got this square root of -1 times the square root of -1, which up here we said that when we have square root of -1 times square root of -1, we can rewrite that as just -1. So that's going to be that -1. And if we multiply 2 times 8, that gives us the square root of 16, which we know simplifies to 4. So we end up with -1 times 4, or a final answer of -4. Our second example is going to be the square root of -9 times the square root of -1. We can break square root of -9 into square root of 9 times the square root of -1. We're going to bring down that -1. And here we have that square root -1 times this square root -1. And we know that that equals -1. And the square root of 9 equals 3. 3 times -1 equals -3. So the square root of -9 times the square root of -1 simplifies to equal -3. All right. And our last example tonight is going to be the square root of -18 times the square root of -8. Square root of -18 we're going to break into the square root of 18 times the square root of -1. So by now you should be starting to see a pattern that anytime there is a square root of a negative number, your first step should always break it into the number times the square root of a -1. So square root of -8 is the square root of 8 times the square root of -1. Here again we've got that square root -1, square root -1. We know that that equals -1. The square root of 18 equals the square root of 9 times the square root of 2. The square root of 8 equals the square root of 4 times the square root of 2. Here we've got this square root 2 times this square root 2. So that just equals 2. The square root of 9 is 3. bring down our negative 1. The square root of 4 equals 2. So I now have 3 times 2 times negative 1 times 2. And when I multiply those all together, I get a negative 12. So the square root of negative 18 times the square root of negative 8 simplifies to negative 12. All right, I would like you to come up with examples that simplify to. So the first problem you're going to do is I want you to come up with an example that simplifies to negative 5. So you get to decide what's an example that will simplify to negative 5. And then your second example is find a number that simplifies to 6i. Okay? And on page 26, we are going to talk about performing arithmetic with complex numbers. So that should be your title. So our first example is going to be 2 plus 3i times 5 minus 4i. And we're going to think of this I in our example like it's an x or a variable. So we're going to treat it just as if it was a variable. When we have two binomials we're multiplying, we have to distribute. So 2 times 5 gives us 10, and 2 times negative 4i gives us negative 8i. 3i times 5 gives us 15i, and 3i times negative 4i gives us negative 12i squared. And off to the right in a thought bubble, I want you to remember that I squared equals I times I. And we know that I is the square root of negative 1, so we can replace that as square root negative 1 times square root negative 1. And we know when we have that, that equals negative 1. So that's going to help us simplify some more over here. First of all, we can combine like terms. So negative 8i plus 15i gives us positive 7i. And now we can change this square root, I squared into negative 1. So we have 10 plus 7i minus 12 times negative 1. And we can multiply the negative 12 times the negative 1 and get positive 12. So 10 plus 7i plus 12. And our final answer is to combine like terms again. So up here, let's just double check that we make sure we're all on the same page. We had negative 8i and positive 15i, and that gave us a total of 7i. And we had this I squared over here, which we changed to a negative 1. And in our very last step, we're going to combine our positive 10 and our positive 12, and that's going to give us a positive 22. There's nothing to combine with our 7i, so our final answer is 22 plus 7i. Okay. So these examples, if you want to tuck over on the side, these examples are both multiplying complex numbers. So our second example is 3 plus 2i times 2 minus 5i. We're going to distribute again. 3 times the 2 gives us 6, and 3 times the negative 5i gives us negative 15i. 2i times 2 gives us 4i. And 2i times negative 5i gives us negative 10i squared. So again, we have these imaginary terms that we can combine together. Negative 15i and positive 4i give us a total of negative 11i. And we're going to bring down our 6 and bring down the negative 10i squared. Oops. And I squared can simplify to negative 1. Okay. So 6 minus 11i minus 10 times negative 1, we can simplify negative 10 times negative 1 as a positive 10. And the last thing we can do is combine our constant terms. 6 plus 10 gives us 16, and bring down our minus 11i. And that's our final answer. We can't simplify it any farther. All right, our next examples are going to be adding and subtracting complex numbers, I know this is a little hard to see because I tucked in that plus in the middle, but it is there. So this is 3 plus 2i plus 2 minus 5i. And when we're adding and subtracting, we need to find like terms that we're going to combine together. So, for example, here is a 3 and a 2. And since those are real numbers, we can combine those together. And over here we've got 2i and negative 5i, and we can combine both of our imaginary numbers together. So the 3 plus the 2 gives us 5, 2i and a negative 5i give us a negative 3i. And that's all the farther we can simplify. There's nothing more we can do there. Our second example is subtracting complex numbers, so 3 plus 2i minus the quantity 2 minus 5i. So remember when you have this subtraction and we're subtracting the whole thing, that this is really like saying we have a plus negative 1 here. Oops, my pen doesn't want to work. So we have to distribute this negative 1. So that becomes, we're going to bring down our 3 plus 2i, plus negative 1 times 2 gives us negative 2, and the negative 1 times the negative 5i gives us a positive 5i. And now we're ready to combine our like terms. So we've got a positive 3 and a negative 2, and a positive 2i and a positive 5i. So the 3 and the negative 2 give us a positive 1, and the 2i and the positive 5i give us a positive 7i. And then we are done.